Okay, this is IGCSE Physics 0625 May June 2020. Uh, Figure 4.1 shows a liquid in glass thermometer without a temperature scale, and the liquid inside the thermometer has a melting point of negative 39 degrees Celsius. Okay, uh, describe some simple experiments to mark the positions of the fixed points of the liquid in glass thermometer. So obviously we need to establish the ice point and the steam point, right? So let's start with the ice point. The ice point, we place the thermometer with melting ice, right? It has to be melting ice. It can't be normal ice, it has to be melting ice, okay? Place the thermometer with melting ice and call it this ice point and mark it as 0 degrees Celsius. And then we want the steam point. Place the thermometer above boiling water, or you could say with steam, in contact with steam, or in contact with steam. And we said mark it and call it the steam point and mark it 100 degrees Celsius. Let's see what the marking scheme says. So place in melting ice, and when we stop, okay, mark as 0 degrees Celsius. Place in steam, right? We have to say in steam. You see, melting is underlined because you need to say melting. Place in steam also has to be mentioned. When the bead or mark as 100 degrees Celsius. Okay, very easy. So this would be just so I can identify the marks. So placed with melting ice is 1 mark. Mark it as 0 degrees Celsius, 1 mark. Above boiling water, that's actually not a mark. We don't care. The marquee was in contact with steam. Okay, and mark it 100 degrees Celsius is the fourth mark. A scientist is measuring temperatures at the South Pole. These temperatures have a minimum value of minus 90 degrees Celsius. State why the liquid used would not be suitable. Okay, if it's minus 90 degrees Celsius, we said here the liquid has a melting point of minus 39. So if it goes lower than minus 39, what's going to happen? The liquid would freeze, right? If it's minus 39, the melting point, it's going to freeze after minus 39. Here it needs to reach minus 90. Okay, so let's see. The bead would not be liquid, or different wording. Yeah, so it would freeze. Or you could say the liquid would freeze slash become solid. Okay, state a design that increases the sensitivity of a liquid in glass thermometer. If you want to increase the sensitivity, that means it changes easier. So if you were to say here is the thermometer, if I change it by minus 0.1 degrees Celsius, it might not change. But if I change it by minus 0.2 degrees Celsius, then you'd see the liquid kind of change. So to increase the sensitivity, I can actually use a thinner tube, because if I use the thinner tube, the liquid's actually gonna be tighter, and the liquid won't like it's gonna be very sensitive. So when it's tight, the liquid will be actually encouraged to move. So every small change in temperature, you're actually gonna see a change in the value of volume of the liquid. So we can say use a thinner tube. And then when we say increases the range, you want more values, right? So if I want more values, obviously I'm going to use a longer tube. So these actually, if you use them together, you'll have the best liquid in glass thermometer. A narrow or thin and long tube. State the property of the liquid which ensures that the scale is linear. We said that liquids expand, right? In a previous past paper, we said that the liquids expand. So it's actually the linear expansion. Since they said linear, you have to mention linear. Okay, the linear expansion of liquids. Because our liquid, when we expand it, doesn't go like this. No, it goes like this, right? It's like if it starts like this, it goes and becomes like this. It increases linear. Okay? So that's question 4 done. Thank you so much for watching. Good luck.